You know, in every modern car, there's this invisible system working hundreds of times a second to keep you safe. It's like a guardian angel you never see, but you're incredibly glad it's there. So today, we're going to pull back the curtain on that very system, vehicle stability control. Let's dive in and see how this invisible guardian actually works. Have you ever been driving, maybe taking a turn a little too fast or hit a patch of rain and had that heart-stopping moment? You know the one, where you're turning the wheel, but the car just isn't going where you're pointing it. It feels like it's sliding or pushing or even starting to spin. It is an absolutely terrifying feeling, that loss of control. Well, that feeling, that loss of control, is precisely what this technology, what we call vehicle stability control, or VSC, is built to prevent. Without it, a simple mistake can send a car sliding right out of its lane. But with VSC, it stays on course. This system, right here, is often the only difference between a scary moment and a very serious accident. So how on earth does it do it? Well, it all boils down to one simple, fundamental question that the car's computer is asking itself over and over again, every single second. And this is the core principle right here. The system's entire job, its whole reason for being, is to measure the gap between your intent, that's where you're pointing the steering wheel, and the vehicle's reality, how it's actually moving and rotating in the real world. As soon as a dangerous gap opens up between those two, that's when it jumps into action. Now, to really get that gap, we have to talk about something called yaw. It sounds super technical, I know, but trust me, it's simple. Yaw is just the car's rotation left or right. Imagine a pin was stuck right through the roof of your car and the car was spinning around that pin. That's yaw. Every time you turn, you're creating yaw. The problem starts when you get way too much of it, or not nearly enough. And that brings us to the system's prime directive, which is this simple formula. Desired yaw rate? Well, that's just your intent. It's how much you're turning the wheel. Actual yaw rate is the car's reality, how much it's actually rotating. The difference between the two? That's the yaw error. And if that error number gets too big, the system knows you're in trouble. Okay, so that yaw error we just talked about almost always shows up as one of two very distinct, very critical types of skids. Let's break them down. On one side, we've got understeer. This is when you turn the wheel into a corner, but the car just kind of wants to plow straight ahead. The front tires have lost their grip. In this case, your actual yaw is less than what you wanted. Then you've got oversteer. This is the classic spin-out you see in movies, where the rear of the car swings out wide. Here, the rear tires have lost grip, and your actual yaw is now way greater than you desired. So to fix understeer, the system does something absolutely brilliant. It doesn't just brake everything, no. It sends a quick, sharp pulse of the brake specifically to the inside rear wheel. Now why that one? Because that single action creates a tiny pivot point, which forces the car's nose to tuck back into the corner, correcting that plow. It's genius. And what about for oversteer? Well, the logic is just as precise, just as clever. To stop that rear end from spinning out, the system brakes the outside front wheel. This creates a powerful counterforce, almost like dropping a small anchor, that immediately stops the spin and pulls the whole car straight. It's just a beautiful little piece of physics in action. Now, all of this happens in the blink of an eye, literally in milliseconds, and it's all thanks to a really sophisticated network of sensors and a powerful little computer. Let's take a look at how this system actually sees the world around it. Think of these as the car's senses. You've got the steering angle sensor, which tells the computer exactly what you want to do. The yaw rate sensor reports what the car is actually doing. Then you have wheel speed sensors at every corner, which are crucial for sniffing out the very first hint of a tire slipping. And finally, the lateral acceleration sensor measures those side-to-side G-forces you feel in a hard turn. All of this data, from all these different senses, is constantly being fed into the car's brain, the electronic control unit, or ECU. The ECU's job is to fuse all those inputs together into one single, cohesive picture of what's happening. This allows it to spot a skid developing long before a human driver could even feel it. And this is the key takeaway, right here. The magic isn't just about braking. It's about using a single brake like a surgical tool. It's generating a very specific rotational force, a yaw moment, to gently nudge the car back where it's supposed to be. That is a level of control you could never, ever achieve with just one brake pedal. So this all comes together in what engineers call a closed-loop system. And what that really means is this isn't a one-and-done kind of fix. It's a continuous, rapid-fire conversation happening between the car and the road.
So it goes like this. You, the driver, make a sudden move. That's the input. The ECU sees this and immediately calculates a big yaw error. That's the processing. It sends an output, an order, to activate one specific brake. But, and this is the crucial part, it doesn't stop there. It instantly gets feedback from the sensors to see how that action helped, and it keeps correcting and fine-tuning its response until that yaw error is back to zero. And this whole loop, it runs over 100 times every single second. It's insane.
Okay, so let's put it all together. Picture this. You're on the highway, doing about 80 kilometers an hour, and it's raining. Someone cuts you off, and you have to swerve suddenly. As you whip the wheel, you feel the rear of the car just begin to slide out. But before you can even panic, you see the stability control light flash on your dash. You might feel a tiny braking pulse from one corner of the car, and just like that, you're straight again. That was the system in action.
Look, this isn't just some clever engineering for the sake of it. This system is genuinely one of the most significant safety innovations in the history of the automobile. Now, you might actually know it by a different name. Toyota calls it VSC. If you drive a BMW, it's DSC. Mercedes calls it ESP. Honda calls it VSA. The marketing acronyms are all different, but the life-saving physics behind them, it's all exactly the same. And the impact on safety is just undeniable. Study after study has shown that electronic stability control reduces the risk of fatal single-vehicle crashes by over 30%. For SUVs, where rollovers are a bigger risk, the reduction is even higher. This tech saves lives, plain and simple. So the next time you're driving and you see that little icon of a skidding car flash on your dashboard, you'll know it's not a warning that something's wrong, it's actually a sign of success. It's your car's guardian angel, using precise physics to keep you on the road. And it really makes you wonder, doesn't it? What other invisible systems are working all around us right now just to make our world a little bit safer?